Thank you. Hope you're having a wonderful Drupal GovCon. Good energy in the room. Going after lunch is always a little difficult. I did, however, go give a talk one time after lunch at Drupal Camp Costa Rica a couple years back. And Red Bull was the sponsor for the conference. So when I came to speak, there was literally a Red Bull on every single chair. So I'm not sure if we'll get to that level of energy here today, but hopefully automatic Drupal updates using visual regression and continuous integration will at least give you a couple tips and tricks to sort of be better kind of folks working with websites. So let's get into it. We've got about 40 or so minutes to dial it in, and then on to the next one. So just a quick sort of deal. My name is Matthew Cheney. I work at a company called Pantheon, and in this role I do a variety of things, but one of the things I end up doing is maintaining websites. Sort of stuff that's already been built, but still needs a little bit of tender, loving care. A little update here, bug fix there, this kind of thing. And I have a bunch of sites for work. I'm sure a number of you probably have sites you maintain for work. I've got a number of my own personal sites. Having done Drupal for about 10 years, there's a lot of sort of websites in the orbit. I've done some websites for friends, and I'm like happy to update for them because they're not as technical. I have some websites for ex-girlfriends I'm less happy about, but I feel we all should have up-to-date websites.
And I'm sorry. It's really loud. Like they can barely speak over you in the next one.
Okay.
I just want to say if you can do anything.
I'll talk. So there's some concern that I'm talking too loud. There's also some concern that's playing like disco music a little too loud, so we tone that down. So I'll pull it back.
Sorry.
My excitement here is real. So let's play that game. Okay. First up, this talk is 4 parts. And part 1 here is really sort of introducing a concept to you that in the Drupal world is not actually that common, but in the world of the internet is very common, and that is automatic updates. If we sort of look at the kinds of applications you might use on your phones or on your laptops on a regular basis, things like Google Chrome, that as new versions of Chrome come out, you will get them automatically updated. That you're not going around telling people you're using Google Chrome 49.4. You're just saying you use Chrome. Same for Internet Explorer, Microsoft Edge. Same for Dropbox. Same for actually WordPress itself. These are applications that automatically update you from one version to the next without you, in fact, having to do much more except for maybe watch the download bar happen. And the reason for that, and this is a huge benefit to the internet, WordPress being something that auto-updates has made the web extremely more secure. Having browsers that auto-update allow for new browser features to be added quickly, and you just have the reality of the people using the most up-to-date stuff, which is good for a lot of different reasons. Drupal has had sort of historically a little bit of a problem with this because Drupal had sort of made this commitment that your content would sort of remain consistent throughout versions, but your code could in fact, and as anyone who's been around for a little bit will tell you, will in fact break on the updates. But one of the things that I think has made this kind of auto-updating world possible now for Drupal is this commitment from sort of the larger Drupal core development team to say that we will sort of commit between different versions of Drupal 8 in particular to having a really smooth upgrade path. That we're not going to break people's APIs without a ton of notice. We're going to give that sort of like easy update experience. Now, it's not automatic updates in the way I'll describe, but this is definitely the right step. And this is something that I think everyone who maintains a Drupal website probably would want to strive for. Because every time that you spend sort of clicking around in an update interface, something you spend running Drush PM update code or clicking buttons to update sites, there are time you could be spent doing something else. And that's sort of what this talk is, how to make this all happen, but also make this happen responsibly using automatic testing and the continuous integration. So the story here and the impetus for this talk was that WordPress has had automatic updates in its core system for a number of years. This means that when a new version of WordPress comes out, WordPress core will check to see if there's a new version. And if there is a new version, it'll actually download the new version, verify some stuff about it, and then plop it right on the file system and have it be the new executable code. And this is, as I said, been a real big win for security of WordPress. That Historically, WordPress has been has had security issues, and especially for people who don't patch those issues regularly, this can be a real headache in the future. Because you have to be sort of clever, honestly, to find new vulnerabilities in CMS software. You have to be less clever to see the release notes come out and say, we fixed this exploit here. To figure out how to exploit people who haven't released is actually quite easy to do. So being able to automatically update people allows us to sort of solve this pain. And there was an example earlier this year where WordPress had sort of come out, it automatically updated. Several millions of people got updated from a security vulnerability they didn't even know existed, but they did not have to worry about. And one of the things that's sort of fresh in my mind is a couple of years back, the Drupal get-in vulnerability that hit Drupal. So at Pantheon, we're a website management platform. We host tens of thousands of Drupal sites. And literally within hours of this vulnerability being released to the public, we were having attacks against sequential alphabetical domains on the platform, clearly against the internet at large, saying, is this running Drupal 7? Is it vulnerable? If yes, then compromise that machine, move to the next one. If yes, compromise. And that these weren't people who figured out this ahead of time. These were people who saw the fact this was a security release, realized what the exploit was by the change in the code, and then started to attack people's websites. And this is a big deal because within 7 hours of the announcement, you have sort of this assumption that your site's probably been compromised if it was running an unpatched version of Drupal, Drupal 7.31 or below. And that's a real problem for people who have things to do and aren't always updating stuff all the time and aren't defining their Wednesday by how many releases they roll out. And that if you've got a scenario like this, which we absolutely will in the future, the internet is full of bugs and things that happen. Even in the best of cases, this is your update process. You're going to have a release that comes out, and if you hear about it exactly when it comes out, you're still going to have to go rush to figure out what it is, get it downloaded, and then apply it to site 1, QA site 1. Apply it to site 2, QA site 2, and on and on and on. And it's going to be literally hours before this sort of cycle is complete. And the big thing, and the big assumption of this, which I think is a little misleading, is that there is no way everybody's always going to immediately when this thing comes out jump on this. People are away on vacation. People have other projects that are more pressing to do. People are out of internet kind of range. All of these things mean this is not your top of your mind. So there's some ways that some folks, especially folks who have maintained larger numbers of sites, will try to deal with this. Because you don't want to have to say, look, I'll wait 2 days and then maybe get to some stuff, right? This is just not an ideal process. And if you start to think about the sites that you maintain and how many of them are fully up to date versus not up to date, that's not necessarily the most pleasant experience. So some folks have tried to sort of improve this by saying, look, let's go create these scripts that says when a new version of Drupal comes out, we're going to run a script to automatically update a bunch of sites and see sort of what happens with that. Now that's actually a little bit faster because we're able to say, look, there's 50 sites, let's just quickly push out the update to all 50. It turns out it's the same kind of work to update one after another sites. But that still takes a lot of time to actually get that script sort of dialed in. This is assuming, of course, you have really good testing and QA environments in all of these sites, which is not always the easiest thing to predict. And then it also assumes you're doing some level of QA on these sites, which can be harder than it looks. Applying a new security update or a core release of Drupal can break a bunch of different stuff. It's not always the front page won't load. There are minor differences potentially in styling. There's a version of Drupal 5.7, I think, that actually broke the taxonomy feeds that could mess up people's syndicated content. There's different sub pages that could be affected. There's a lot of minute things that are actually really important to get right. And the last thing you want to do is have a site that works and then update it and then it not work. So even within this process, this can be, of course, a little tricky. So one of the concepts I want to talk about today that I think is probably a big thing to sort of leave with is this concept of using visual regression testing. This is a process I'll talk about, but I think it's really the missing piece to this process of being able to quickly script your updates, quickly test that results, and then quickly deploy. And I'll show you some version of a live demo today, depending on how healthy GitHub is. So here's the sort of first piece of this kind of puzzle. And this is the idea of a continuous integration sort of process. Are there folks in the room that are using continuous integration reliably right now for your projects? Or folks that want to in the future? So I work with a lot of agencies who are sort of ramping up their development process and really see continuous integration as the future of web development practice, like DevOps. I think coming out of the keynote that Michelle gave earlier today, getting this stuff right actually can save a lot of time. That, we have the robots that will pick out our outfits for us with Amazon's Alexa. The robots will drive our cars. They're clearly raising our children. The least we can do is help to make them do a little website work. So, at least when the robots rise up, they'll understand we made them test IE, so they have just cause for this kind of action. But in the website world, what this allows you to do at a sort of base level with CI is say, we've got a version control repository over here that contains our code base that we want to deploy. And then we have a series of scripts that we write and we test for everything that needs to happen before deployment. So that might mean we need to run Composer. Composer will take a bunch of dependencies to build Drupal and modules. We might want to do some Sass compilation and take our Sass files and turn them into CSS. We might need to do some stuff with CoffeeScript. And then, of course, we might need to do a variety of automatic testing. And this allows us in CI world where we're able to basically say, for every commit, let's go ahead and run 10 different tests to see if it breaks the site, to see if the code standards are up to snuff, to see if there's security issues. And building this into your process can be a really healthy thing. My friend Jody Hamilton gave a talk earlier this morning on sort of continuous collaboration, and it sort of reflects this kind of value. It says, on a large team, everyone who does a code commit should have some kind of robotic analysis of that code commit before a human even looks at it. And this just creates a more virtuous, I think, development process as a team. It also opens the door for a lot of kind of things I'm going to talk about today. And the deal, though, with continuous integration is that this is something that typically requires a third-party service to use. So you have your laptop, you might be working on code, and you have your production host that's actually hosting the site. But you typically need a third-party sort of additional service that sits in the middle and sort of says, okay, whenever I detect a code push to my GitHub over here, or to my internal Git server, then spin up a new sort of set of things in the cloud, run the tests on those things, run the notifications to tell people on Slack this is happening, do the code analysis, for a coding standard review. And then if things look good, go ahead and push it to a QA environment on a sort of host kind of procedure. And so Circle CI and Travis are probably two of the larger companies that offer this. Service Provo CI, another one, that will basically be services you can buy or use that are going to do this for you. And then there's Jenkins over here that is sort of the open source version of this. You can host yourself and use Jenkins. All of them basically do the same thing. The key is that they watch a Git repository, and when code changes in that repository, they run a bunch of scripts. And then from that scripts, they can do things like deploy code. And I'll walk you through one of these scripts here, but it's the kind of thing where getting a version working, if you've got a spare afternoon or at this conference, that really helps to sort of get the full cycle of what's going on. Because it's new. It's not like what maybe previously website development had done, but it is where a lot of this kind of world is going. And it's necessary to do what I'll show you next. So see.
Does Team City fall into this category?
Sure. Yeah, there's a lot of players that are trying to build versions of this. Depends a lot on the nature of what kind of features they're trying to offer. What I'll show you actually is a bash script at the bare bones, so you can sort of write your own bash script. But having additional kinds of services that offer smarter things only saves you time. So this is what the interface for, I'm going to show Circle CI off just because they're from San Francisco, I'm from San Francisco, so we'll do a little bit of this. But it's all about the same. It's all about the same thing with different features to speed you up. But the idea is that you walk through a series of steps every time a Git commit is made to your repository, and it will do things to help you along your way. So that's sort of ground stakes. You need some kind of CI system to sort of be watching this kind of stuff. You can either have the CI system, as I was saying, watch on every Git commit that happens, or you can have a CI system that just runs every hour. And that's going to be important when we talk about security updates, because every hour we want to like kick off some analysis and see what's going on. But here's the missing key. So in the world of automatic testing, there's a lot of different kinds of tests that you can run. You can do unit tests, you can do behavioral tests like BHAT, you can use performance tests, load tests, accessibility tests. But the test that I think is most important for security updates is a testing solution called visual regression testing. And what visual regression testing is it's sort of using something like machine vision to basically look at two copies of a website or a video game or some sort of software and compare a before and an after version of those kinds of things. And the idea is that you can take like a snapshot of your homepage before you make a change, and then do a snapshot of your homepage after you make a change, and then the computer will go pixel by pixel through that entire homepage and detect any specific difference between them. This is something that allows you to quickly dial in very obvious changes of when stuff what's actually been changed and when. So this is powered by, there's a service called Wraith that the BBC developed early in its sort of internet days, where the BBC has a lot of complicated web properties. They would push out different changes. They've got 10,000 pages. Instead of having people go through each individual page to see what the differences are, the Wraith robots would look at all 10,000 BBC pages and give a report back that says, here are the pages on which there were changes, and here are the things that are changed. And there's been a number of other newer solutions. There's a backstop.js solution I'll be showing off today, which simply does the same thing. Takes a screenshot before a change, takes a screenshot after the change, puts them together and tells you what's different. So let's take a little example here. This is a website from the very excellent Panoply, which was the Drupal 7 distribution of panels. Not that important, has some pictures for vegetables because I made it and I'm a vegetarian. But here's another version of it. So if you're not fixating on the vegetables, version 1, version 2, putting them side by side. Now there are differences going on here. You might be able to sort of spot sort of what's being changed on them. But it gets way easier if we have the computer sort of compare and look at the two pixels. Because it can go all through the header, notice no differences, gets down into the homepage and the things that are like high vibe red, those are the actual changes to the pixels that are happening. And this is the kind of report that you can get. Now, as a sort of developer in a team, this may or may not be helpful to you, right? Like if you were told to change some stuff on the web page, stuff is going to change on the website. That's not like a broken test. It's just the work that you did. Building websites is in fact moving pixels around. But it's used sort of to help you identify things. Like maybe you were just trying to change the titles on the homepage to a different color. But for some reason, this little read more link sneaked in because it actually is an A link on the page and you were just targeting A links and somehow your CSS changed to read more link when you really only wanted to get the other three. And that can be helpful just to really dial in what actually has changed. It makes your human time sort of very, very valuable to look at that. It's possible. What's really also helpful is you can also really expand this. So you can do this not only for just the desktop version, but you could also do it for a mobile or a tablet. You can specify your different breakpoints. And you get reports sort of that look like on the left, where you have different kinds of versions. There's a reference image and a test image. Those are the two comparisons. And you'll see, hey, we've got some padding that moves some stuff down. We've got different alignment issues. And you can start to see these are different kinds of errors, but it sort of overlays that. And it gets you these error reports out on the right, where you can actually even set thresholds. You might not even care if it's only 2 pixels that are changed. You only care if it's more than 10% or something. And there's a lot of people that build this into their development process. And if you're in a high fidelity kind of environment where pixel perfect is the kind of phrase you throw around, this is really helpful because it actually maintains pixel perfection. Where this falls down, I think, as just sort of a general purpose testing tool is that there's really a lot of noise in this testing process. That every time you make a change of substance to your site, that typically involves changing the pixels on your site. And many sites that we might build might have like a rotating quote or slideshow on the site, and that could be different depending on what's going on. There's a lot of false positives that can get in there. If you change something on the sidebar, I'd show every page on your site's changed, but that's not actually that big a deal. Or maybe font sizes will change or something will modify in a sort of way that's totally fine for your project. And the problem with visual regression testing is that the robots who are looking at your site sort of have a problem understanding like what pixel changes are like no big deal and what pixel changes are like serious for the site. And in the world where our jobs are to change pixels, we start to get a lot of visual regression kind of noise. And this can be sort of hard as we're sort of looking to build a development pipeline involving this kind of stuff. Where this thing really kills, though, is in the context of a security update, all right? Because security updates, for those who have looked at them, are actually relatively simple bits of code. This is the security update for the Drupal Get-In release, that in order to make a site super insecure and subject to pre-auth SQL attacks, you do a for each without an array values on your data array. To secure yourself, you just throw that array values in there, and you're good to go. That's like literally the only change that was required to make Drupal Get-In happen. Now, this is extremely meaningful when you're passing these like complicated like parameters at the Drupal site because the exploit used those array values to like actually run code and override UID1 kind of permissions and things like this. But that's only if you do a sort of wacky set of things to it. A normal website, turns out this security change does not require changing any pixels on your site to be more secure. And this is, I think, really important. That there's no security update that I'm aware of that's required a pixel to be changed to make the site more secure. It's usually all filtering of data or output or like doing some sort of additional access check. But it's not requiring your homepage to look different to be a better and more secure site. And so the idea then is if we actually run our visual regression test, and this is a test site that I have, and we look at what it looks like before the security update, and we look like what it looks like after the security update, guess what? They are exactly, pixel by pixel, the same. There's no difference between them. Because why would there be? We haven't changed any pixels, we've just added some security stuff on the backside. And this allows us, if we understand this test, this allows us to get the missing piece here. Because before, in the world where we're trying to automate our security updates, by automated, I don't just mean when an update comes out, apply it to my live site and hope that it all works out, right? Like I have some standards here to actually verify that the update is not going to break my site. And breaking my site, by the way, a big red error box at the top of my site, that is also pixels that are changed. So I don't want that. But I am comfortable with relatively reasonable kind of testing, the equivalent of me clicking around on all of the pages. And in order to get this to work, I put the two pieces I just talked about together. We have a continuous integration system that checks every hour to see, hey, are there new updates? If so, let's create some QA environments for those updates. Let's see if there's pixel differences. And then the visual regression test that can look at those pixel differences and say, okay, there are or there are not. And then if there's not, it can go ahead and deploy it. So what does this look like as a workflow? So we literally can ask the robots to tell us every single hour, are there security updates available? And if there are, or if there's none, if things are up to date, that's super great. We might even want us to tell us that we can email our clients or our bosses. We can say we've checked the site for security updates 24 times yesterday, and everything was up to date. We're totally fine, and we've created some value. We can invoice or at least feel good about our time, right? This is valuable. Checking if your sites are in fact secure is something a lot of agencies I've seen and folks who work here on different projects, that's part of their job, making sure stuff's up to date. Checking every day, part of your job, get it right. And do very little work, right? You're functionally reading an email once a day saying, we checked 24 times, it's fine. There obviously are cases where there are going to be updates, Drupal core updates, every month, 2 months, contrib obviously a little more frequently, depending on the contrib. And in those kind of cases, we start to run scripts that say like this, look, if we've got a new update, we want to test it. but we're not interested in testing it like on the live site. So a really great thing is we can just use a version control system like Git. We can create a new branch called like update. We can actually then we'll want to take a snapshot of our live site database and files. So we can do a MySQL dump and an rsync to bring over that content. So we have the latest and greatest from that live site. We'll go ahead and apply that new commit using something like Drupal console or Drush to easily push those in. And then we can actually start to run our visual regression testing to compare that before and then after kind of version. And that's something that allows us to see if things are broken or not. And I also want to emphasize, visual regression testing is not 100% of what you might ultimately need. I think it works well in almost all cases. But for other things, add additional testing, feel free. Part of continuous integration is that you can add additional layers of testing as much as you want. I mean, definitely do visual regression, but if you're like e-commerce site, throw in a BHAT test for the shopping cart to make sure that works, or check your RSS feeds, or check logged in user search. Whatever is important, you can add this in. You've got that continuous process to really dial it in. And you sort of run these tests. And then you do your comparison, see if your tests pass or not. If your tests pass and there's no issues in testing, like your BHAT tests are cool, your visual regression is no change, then you can go ahead and actually start to get this thing out there. So merge it in your master Git branch, deploy it out to maybe your more formal QA environment. Maybe notify someone on Slack this is happening, maybe not. Run any other testing you want before final release. If you get into the testing world, you start to add a lot of tests just because you're like, let's more tests. It's fine. And if all that's still good, you can deploy your updates out to your live environment. Maybe make a backup before, depends on your level of confidence. And now you can invoice or have your job be done. But the idea is that all of this can happen in a set of scripts. I'll show you in a minute. It's actually very little code when you're taking advantage of things like Drupal console and Drush to do Drupal operations, and you have command line kind of interfaces to your web host, or you want to build something that can sort of easily move databases around. You, of course, do run into issues from time to time where there are problems with the tests. Things are different than what you actually expected. And in those cases, the robots aren't necessarily going to know what to do. That's okay, though. We've done a lot of the work already. We have a Git branch. We've already seen what pages in it fails. And we can get a report back from our robot saying, look, we looked at 900 pages on your site, and 2 have visual changes. A human should go look at those 2 pages. But it's way easier to start with a site that says, here's the update that's broken that has 2 pages different. Go put your brain power to it. Than sitting there being oh, there's a tarball of a new Drupal over here. Let me do something with that. It really focuses your time and attention on stuff that actually kinds of matters. And then you can QA and do your manual review and fix it and then run it again. And you'll go through. So let me show you how to pull this off. So you do need some sort of continuous integration solution, like I was mentioning, Circle, Jenkins, Provo, Travis, one of these. A number of these offer free tiers as well. So one of the reasons I also show off Circle is that it has a free tier you can set up today. So just having it and you can play around with it without having to, just to evaluate it. You do need some command line tooling, so like Drupal or console or Drush to access your site. And then something like Terminus or Aqueous CLI or some sort of tooling to be able to set up development environments in the cloud or otherwise. And this could also be a custom bash script that you wrote. If you've got your own production server that has a create spin up branch kind of command, that's basically what you need to do. And then you having some sort of hosting platform that you can call these scripts on is of course pretty important. And I do have code available to work on this, which I'll show in just a minute. GitHub, com, Populous, Drupal Update. And Kyle Hall, thanks to him, he helped to work on this as well with me. And let's go see it all going. So let's go see. We had a slight issue. Okay, coming back. So one of the downsides of running this in the cloud is that you are subject to cloud providers' availability. GitHub is coming on back. It had an issue earlier today. But let me go ahead. I'll show you what this actually looks like, because that's probably the coolest piece. So what a continuous integration script kind of looks like is it's something that exists in a Git repository, typically with your website code. And what you have is you have a single file, in this case circle.yaml. And this is the file that actually is the instructions of what to do, all right? And it can look a little bit daunting at first. There's a lot of little like things that do things here and there. But this is the sort of like instruction set to the robots. So every time it has a new commit, or every hour when it's run, first thing we do, we set the time zone to Chicago, because that's what I said in my script. We, PHP requires a time zone to be set. It has to be set to something. It doesn't really matter where. We're going to go ahead and install a version of Node, because that's used to do our visual regression testing using backstop. So we actually are going to set up a machine that has Node and a machine that has PHP, and we specify the versions. Then we're going to go ahead and specify a few variables. These are just things we can call in our script. In addition to these two that I have here, this is my branch name for my updates, and then my path. There's some secret UI, secret stuff I've added as well, like my machine token for my command line tool, a Slack channel, a Slack URL to kick it out. From a sort of security standpoint, those are sensitive tokens that are important to me, and so they're stored in the Circle database. The actual GitHub script just assumes they're there because Circle will automatically inject them in the environment. And then I set up some caching just so it goes faster each time. But the really important kind of stuff that happens is I'm like, okay, I want to start doing tests. And the key thing to think about continuous integration is every time the script runs, it actually starts up a whole new container, a whole new VM that you get to work with, a whole sort of fresh environment. So anything that we need to actually set up ourselves. So I already said we needed Node and PHP, but on top of Node, we want to go ahead and get npm install backstop and backstop for our visual regression testing, Slimer.js takes screenshots. So every time we run this, we're just going to get this package, but that's totally okay. And then we're going to do a composer global require intake and terminus. This is a command line interface to Pantheon, lets us call like setup dev environments. And then we're just going to call our bin Drupal auto update script. So real straightforward, PHP, Node, get some stuff going. And then when we actually run this script, this is literally a bash script that Kyle and Andrew wrote that actually goes in and just does the kind of things that you would want to do when you have an update. So it says, and these Slack notifies things are just things that push it out to Slack so you can see, but it says, log into our command line tool, go ahead and create a multi-dev environment. That means take a Git branch and create a sort of PHP, MySQL, and file system based on it, and pull the stuff from the live site into that. And then go ahead and check to see if there's any like upstream updates. That means if Drupal core has been updated. And if Drupal core has been updated, which is just a simple Drupal console or Drupal Drush command, you could go in and say, okay, if there's no updates available, like it's up to date, which is like what it's going to be like almost every time, then just go ahead and say, great, echo back, no upstream environment, no upstream updates are found, move on. If there are updates available, you could actually go ahead and apply those things. This is the command line tool using Terminus to do the application. You could also run a variety of other. You could run a composer update if you wanted to do this as well. And that'll actually then update yourself on that multi-dev branch to the latest version. And then you can do the same thing for Drupal modules. In this case, we're using Drush, but you could use Drupal console or other methods to basically say, run pm update status. That'll just show you if there's any modules that need to be updated. If there's nothing that needs to be updated, do nothing. And if you do have stuff you need to do, go ahead and there's another command called pm update code that actually will just apply those updates directly. And then, without doing a whole lot of work, right? We're just saying, see if there's an update and then run a command line tool to do the updates. We're able to functionally script our updatability and get that all working. And then we'll go ahead and commit that to the Git branch just so we have a record of it. So pretty simple stuff maybe you're used to doing on the command line anyway. Where the magic comes in is actually in the visual regression, of course. So if there's no updates that we actually need to test, we literally do nothing and move on. If we do have updates to test, we actually want to run that visual regression test. So running the visual regression test is actually just two commands. It's backstop reference that creates our reference images, and then backstop test that does a test between them. And we can actually see there's a sort of a command line file for this called backstop.json. And this is actually the sort of command syntax for actually what's going to be tested. So this is just we're testing just one desktop display with these dimensions, and we're testing these two URLs. And it actually will go ahead and just test those. If you get this thing called mismatch errors, that means there's differences, at which point it says QA fails, go ahead and check manually. But if it doesn't, if it passes, there's 0 pixel differences, and let's just take it all the way. Let's merge it into our dev and test environment. Let's create a backup, and then let's deploy it to the live site. And that's all made possible by something like a terminus or a command line where you can ping your production server and say, take this commit, push it to my live environment, or take a backup of my live environment. And this is just bash kind of scripting that's being done. So you can basically do anything you're able to do on your local like command line, you can do it this way. And one of the things that I sort of do to help it is I usually have a Slack channel I'm working in where I can actually see what's going on. So I have a version of this where I actually kick off into the Slack channel sort of what's going on. So I read this a little bit before, so I wasn't so confident in the GitHub. But it's saying, hey, let's go start a new circle build. So we're going to check. Let's see what's going on. Hey, we've got some updates to apply. Great. Let's go apply those. Hey, we have some contrib updates to do. Let's go apply those. Let's go ahead and check stuff for testing. Key test here, no visual differences detected. And because that's the case, we can go ahead and deploy to dev, deploy to test, create a backup of our live environment, and then deploy to live. And with that, we can get a little picture of our site at the end to say things are hunky-dory. And this is the kind of thing that you can run over and over and over again. Because every hour it can do that same kind of process. The robots are completely happy to sort of vibe it that way. And getting it all sort of squared away and tested can really help your sort of situation. So that is the nitty-gritty of what we're up to. And with that, I want to sort of thank you and turn over to QA, but we'll just emphasize that security updates are something that exists as things that regularly happen in our developer lives. They're things we do the same thing every time to apply them and check them. And with a little bit of work to create a little bit of bash code and glue code and a little circle integration on top of that, we can have the robots do this all for us. So with that, thank you for paying attention to my talk.